Today we're going to factor sum of squares. Now, if you remember when we were dividing complex numbers, we had to use this formula, which was a squared minus b squared, and we said that was equal to a plus b times a minus b, right? But now what happens if instead of having a subtraction, we have an addition? So let's say we have a squared plus b squared. So now in this case, if we want to factor this expression, we have to do the following. It's going to be a plus ib times a minus ib. And now you see the only difference is that we added the imaginary number, right, which is I, to one of the terms, right? But now let's prove this. So we want to know if what we have here is the same as what we have here, right? So let's see. If we multiply these two expressions, right, we're going to end up with a squared minus aib, right, plus aib minus I squared b squared, right? So now we see that these two terms get cancelled and we end up with a squared minus I squared b squared, right? And remember that we know that I squared is the same as -1, right? Then times b squared. So finally we end up with a squared plus b squared, right? So as you can see, we end up with the same expression as we started, right? So that means this formula is correct. All right, so now that we know this new formula, let's get started with the exercises. So we have a, which is equal to x squared plus 64, right? And again, all we have to do is just apply the formula and we are going to end up with x plus i8 times x plus, minus i8, right? And it can also be written, it would be better if we have x plus 8i and x minus 8i, right? So now for b, again the same thing, we have 9b squared plus 25. So we're gonna have 3b plus 5i times 3b minus 5i, right? And then finally c, we have x squared plus 1. So if we factor this, we're gonna end up with x plus 1 times I, which is basically I, and x minus I times 1, which is again I.